Welcome back to the deep dive. Okay, if you're a technical pro managing Azure stuff, maybe grab your notes because this week we're really zooming in on a few key updates. These are from October 20th to the 23rd, 2025. And honestly, some of them need your attention pretty much now.
That's right. We're not wading through every little tweak today. Our goal here is to really filter down to let's say, the critical announcements, things that demand planning, retirements coming up, or features that give you genuinely new ways to handle cost and performance. The big themes, I think, are sort of mandatory modernization on one hand and surprisingly more granular control on the other.
Okay, yeah, let's unpack that. Starting with where the clock's really ticking, those critical timeline shifts.
Yeah.
Nothing gets people moving like a hard deadline.
Yeah.
And we've got a couple of major ones demanding attention. First one's in the AI space.
Indeed. We absolutely need to flag the planned retirement of the Azure Computer Vision Image Analysis Service. This is the V1 service. It's been pretty widely used, so if your applications depend on that specific API, well, you've got to start planning the migration off it.
Right, but for anyone using it right now, it's not like immediate panic stations, is it? Microsoft has laid out a pretty clear runway. Full support for existing customers runs until September 25, 2028. So that gives you time, yeah, but it also means AI modernization has to be factored into your next few architectural refresh cycles. It's on the roadmap now, like it or not.
And if you think 3 years is generous, the pressure is frankly much more acute over in the networking stack. We've definitely seen an accelerating push to migrate away from Azure Application Gateway V1. That's the standard, or the WASQ. Oh, over to V2, obviously. Standard V2 or WAF V2.
The V1 App Gateway deadline. That's the big one, isn't it? Retirement set for April 2026. That's just over a year away, which feels, very tight for a foundational network component that often sits in front of, well, hundreds of services sometimes. And historically, V1 to V2 migrations, they've been kind of notoriously complex, right? Lots of downtime, manual config.
Oh, absolutely. A huge headache. I remember organizations just stalling on the V2 migration simply because, well, re-architecting the public IP space and managing that whole cloning process, it was just too error-prone. Too much risk of a major outage.
So what's the relief then? Because it looks like Microsoft is perhaps acknowledging that pain point by releasing some new tools.
Precisely. Yeah. To ease this mandatory shift, there are 2 key support tools now, generally available: enhanced cloning, and crucially, public IP retention PowerShell scripts. Being able to keep that public IP address during a full app gateway reconfiguration, that's a monumental simplification. These tools are really designed to automate and de-risk what used to be a multi-day, high-stakes manual job. If you're still on V1, seriously, run, don't walk to check out these scripts. Top priority.
Okay, so that connects the stick of modernization directly with the carrot of practical tools to actually get it done. Good. All right, moving beyond the deadlines, let's talk about the control we're getting. Section 2 is where maybe platform engineers get to geek out a bit on compute. We've got a public preview that gives incredibly granular control over VM configurations.
Right. This is where we shift from mandatory stuff to optional but potentially high-impact optimization. The public preview of VM vCore customization features, arguably the biggest technical lift this week. It fundamentally changes how you configure virtual CPUs in your VMs. And that has, well, profound implications for performance isolation and, yeah, definitely cost management.
And there are 2 specific features in this preview people should really look at. First one, the ability to disable simultaneous multi-threading, or SMT. Intel calls it hyper-threading, HT.
Disabling SMT is critical for certain workloads. Think latency-sensitive databases or maybe high-security environments. SMT lets physical cores run 2 threads at once, which is great for throughput, generally. But sometimes, for compliance or strict security, you need that absolute performance isolation. Disabling SMT means 1 core, 1 thread, period. It isolates the workload completely and can help mitigate certain side channel vulnerabilities too.
Okay, so that's performance and security. The second option, constrained cores. That sounds like it's all about the money, specifically licensing costs.
Absolutely. This lets you effectively hide physical cores from the operating system and the apps running on it. Why does that matter? Well, a lot of expensive third-party enterprise software, think Oracle, certain database platforms they license based on the visible core count. Doesn't matter if you actually use them all. Constrained cores lets you tailor that vCore count precisely to what your application needs. So you can pay the vendor only for the cores you actually expose. That could save, potentially astronomical amounts on those per core licenses.
So you're essentially trading away some physical potential you might not need for very defined Cost control. That feels like a massive strategic lever for architects.
It really is. It's a direct response to a major pain point,
Right.
especially in hybrid cloud setups.
Okay, so if we have that level of control over the cores, the next logical question is, what about control over the capacity itself?
Hmm.
Managing capacity across complex orgs, loads of subscriptions for different teams, that's historically been a bit of a nightmare, hasn't it?
Yeah, that rigidity is starting to ease up now with the public preview for sharing capacity reservation groups, or CRGs. Before this, if you reserved capacity with a CRG, which guarantees you resources, you could only deploy VMs into that group from the exact same subscription that owned the reservation.
Which was incredibly restrictive. I mean, dev, QA, production, they're often in separate subscriptions for governance reasons. So you'd have reserved capacity just sitting there, maybe unused, because the right consuming subscription couldn't actually access it.
Exactly. The key takeaway here is simple. You can now share CRGs with multiple subscriptions. This allows for much more consolidated capacity planning, reduces waste from unused reserved resources, and lets large organizations use their capacity way more efficiently across different business units.
Wait a second, though. If we're sharing CRGs across subscriptions, how does that work for cost allocation? Like chargeback within a big company. Does the original subscription that bought the CRG still foot the entire bill? Or can Azure somehow split the operational cost based on who uses it from the other subscriptions? That seems like a major governance hurdle.
Ugh, that's a really crucial point, especially for FinOps teams. Good question. As it stands, the reservation cost is still tied to the subscription that created it, so the complexity of chargeback. That remains an external governance challenge for you to solve. You'll need really robust internal tagging and cost management policies to track who's using what across those consuming subscriptions. The feature solves the technical deployment block, definitely, but yeah, it does introduce a new accounting layer for IT finance to manage internally.
Noted. So the tech moves forward, governance has to play catch up. Okay, let's pivot now to databases. The theme here seems to be immediate: GA speed gains and more flexibility. Started with Azure Database for PostgreSQL.
Yeah, we've hit near zero downtime scaling for high availability HA-enabled Azure Database for PostgreSQL servers. This is GA now, and that's a huge operational feature for any service with really stringent SLAs.
The numbers here really tell the story, don't they? Traditionally, scaling Postgres databases, you were looking at maybe 2 to 10 minutes of interruption, something like that. But with this new GA capability, the scaling process is now consistently under 30 seconds. It's almost negligible downtime in a high-traffic setup.
It absolutely changes the game for using PostgreSQL for truly critical, high-availability applications. Makes it far more competitive with other managed database offerings, just purely on operational efficiency during scaling.
And is that 30-second scaling now competitive with what you might see on, say, managed services from other cloud providers?
It certainly closes the gap significantly, yeah. I mean, many competitors get fast scaling by doing clever things like redirecting traffic to a replica and promoting it quickly, but consistently hitting under 30 seconds for a fully HA Postgres server during a scale-up, that's impressive engineering, puts it right in the top tier for operational performance.
Okay, moving over to Azure SQL then, what improvements landed there in the mid-October GA updates?
We saw two pretty significant enhancements. First, they promoted the redirect connection type to be the default connection method for Azure SQL. This type is generally preferred because while it establishes through the gateway initially, it then lets clients connect directly to the database node itself, much faster. But the key change here is that it now only requires port 1433. That simplifies networking requirements quite drastically.
Simplifying networking is always good news, but the flexibility gain, that involves the hyperscale tier, right?
Yes, exactly. There's a new capability now to convert an existing Azure SQL database to the hyperscale service tier. While still preserving any existing geo-replication setup you might have, this is a major unlock. Previously, if you were using standard geo-replication for DR, moving to hyperscale, which gives you that massive storage scalability, was incredibly complex. You often had to break and then re-establish that geo-replication link. A risky process. This new feature lets you do the conversion with the replication intact. It removes a huge barrier for orgs needing massive scale, but absolutely cannot compromise their DR configuration.
Removes the risk from that architectural choice. Makes sense. Okay, finally, let's wrap up with updates focused more on workflow efficiency and dev tooling, specifically around cross-cloud mobility.
Right. For organizations juggling multiple cloud environments, Azure Storage Mover keeps evolving. Its newest feature, AWS S3 to Azure Blob migration, is now generally available.
This sounds simple on the surface, but for multi-cloud architects, this feels crucial for governance, doesn't it? It means you can now securely, reliably move data directly from S3 into Azure Blob Storage at scale. And critically, it eliminates the need to build, maintain, and secure all those custom intermediary pipelines or VMs just to shuttle data across.
Exactly. It automates a major friction point in cloud governance, especially when you need to move massive data sets for consolidation or analysis. And then on the developer tooling side, we saw a pretty exciting open source contribution, the launch of Containerization Assist MCP server.
Okay, tell us about that. What's the single biggest win this open source tool offers developers?
The single biggest win, I'd say acceleration through automation. Pure and simple. It directly tackles the problem of manual, time-consuming, and frankly error-prone containerization work. This tool automates pretty much the whole process, creating Docker files, generating those complex Kubernetes manifests. And importantly, it's built on the proven foundation of AKS Draft, so it leverages that established reach. It offers a mature, end-to-end containerization platform, not just some basic script generator. The real aim here is to speed up container adoption by slashing the effort needed to get an application from, say, a VM to actually running in Kubernetes.
So if we look back at everything we covered just now, from mandatory V1 retirements and that new vCore customization for cost control to near zero downtime database scaling and simpler S3 migration, the message seems pretty clear. Azure is sort of simultaneously demanding modernization while also giving technical users these unprecedented levels of control and speed.
That duality really defines the modern cloud architecture challenge, doesn't it? It's this environment of, yes, increasing control, but also accelerating mandates. So the question you probably need to answer this week is this: where are you focusing your resources? Are you dedicating time to proactively optimize your existing environment with these powerful new tools like, say, the vCore customization? Or are you prioritizing hitting those V1 retirement deadlines? Because focusing too much on the, let's call it, freedom offered by new features might mean you're ignoring the immediate hard deadline risk imposed by those mandatory retirements. Finding that balance is key.
That challenge of balancing the freedom to optimize versus the necessity of mitigating risk. That's the strategic decision on your plate right now. Well, thank you for joining us for this technical deep dive into the latest Azure updates.
My pleasure. Always interesting to see what lands each week.
We'll catch you next time.